Hello everyone, my name is Rishikesh Kale. I am a third year engineering student in the field of electronics and telecommunication from Jawaharlal Nehru Engineering College, Aurangabad. First of all, I would like to thank Emertxe Institute for providing us the wonderful free internship program on IoT. This internship program was of about 4 to 5 weeks in which I learned variety of aspects of technologies such as IoT, embedded systems, etc. So starting with my presentation, the contents of my presentations are the internship goal, what is SDLC, basics of C and C++, embedded systems, Internet of Things, software used, IoT app and cloud, project requirement, project image, and finally I will be showing you the simulation of the project. So what was the goal of the internship? So the first goal was giving us the exposure how to implement the project the industry way. In colleges, many students simply copy the projects from different sources like Google, YouTube, etc. By doing this, students do not get enough knowledge about the actual project. So unlike this, in internship we were taught how the industry works on a given project and what proper planning and execution is needed while doing the project. And of course the second goal was understanding the IoT. The first topic that was taught in the internship was basics of the languages like C and C++. All the aspects of C and C++ that were needed for implementation of the project were taught thoroughly. For example, the main topics like data types, functions, what are macros, and importance of pointers, classes and objects, etc. Next topic is embedded system. An embedded system is a combination of computer hardware and software designed for a specific function. So basically embedded system is an electronic system that is designed for specific task or number of tasks. Some embedded systems can be programmable by the user end and some have fixed programs that are programmed by the manufacturer. The typical embedded system examples are AC remote, cars display, or we can say calculator, etc. So components of embedded systems. What are the components of embedded systems? So the first component or the main component is sensor, then analog to digital converter, processor, memory, digital to analog converter, and the actuator where we take the output. So the sensor examples LDR, temperature sensor. These sensors are used to give input to the processor, but before that we convert them from analog to digital values, as processor works on zeros and ones, that is it manipulates only binary bits. So analog to digital converter is used. There are digital converters as well as analog converters. So for analog sensors we use analog to digital converters. The another main part of or the brain of the embedded system is processor. It gives all the instructions to the sensors, what to do, what not to do, and other parts of embedded systems. For example, in Arduino, Atmega 328 is the processor of Arduino Uno. What is IoT? Internet of Things or IoT is the network of physical objects that contain embedded technologies to communicate or sense or interact with internal states or external environment. IoT is nothing but the embedded systems that are connected to internet to perform the required task. The examples of IoT are Amazon Alexa, home automation, Tesla cars, smartwatches, health monitoring systems, etc. IoT around us. We are surrounded by Internet of Things knowingly or unknowingly, we are using the Internet of Things. For example, online shopping, smart wearables, smartphones, Tesla cars that contain that have internet or AI technologies to drive, that is using internet, home lighting to control fans, switches, lights of home and appliances, that is fridge, washing machines that are connected to internet. We can access the fridge and washing machines from distance location. Music, personal computers, data analytics in flights and services. So IoT architecture. The three components of IoT architecture are data connectivity, data processing and analytics, and then the presentation. So what is data connectivity? Data or device connectivity is connecting devices to internet. There are some IP capable devices, existing IoT devices, and low power devices. Low power devices are the devices that doesn't have internet facility inbuilt in them, so we need some external circuit to connect them to internet. Cloud is nothing but the storage where we store the data. So the main part of this IoT architecture is data processing and analytics. Simply connecting the data or devices to IoT won't help. Performing some operations and obtaining some important results by processing the data input by this IoT capable devices and obtaining the result is important, and then presenting it to the user. So now, after acquiring the skills about languages, embedded systems, IoT, time to implement those skills. So the problem statement of this internship project was IoT based home automation solution. The software used in this projects are Arduino IDE, PicSim Lab, Num Emulator, Blink App, Blink Cloud. Arduino IDE. The Arduino is an integrated development environment, or Arduino software. Contains a text editor for writing code, a message area, a text console, a toolbar with buttons for common functions, and a series of menus. It connects to Arduino hardware to upload programs and communicate with them. This is the interface of Arduino IDE. This area is of the file name, toolbar where we can compile and verify our program. This is the where we can know the IDE version, that is 1.8.12 that I am using. Text editor for writing code, and this area shows the error messages. The next software we are using is PicSim Lab. PicSim Lab is a real-time emulator for development boards with integrated MPLabX AVR GDB debugger. PicSim Lab supports some PicSim microcontrollers and some SIM AVR microcontrollers. PicSim Lab have integration with MPLabX and Arduino IDE for programming the board's microcontrollers. This is the interface of PicSim Lab. From tools or microcontrollers, we can select the Arduino Uno. These are the control pins. We can see the status of active pins and low pins. So the board we are using in this project is Arduino Uno. The main processor is Atmega 328 microcontroller. These are the digital input output pins where we can get the values of maximum up to 5 volts and minimum 0 volts. These are the analog pins which are used for analog input. This is the crystal oscillator which gives timing cycles to this microprocessor. and this is the USB connector from where we can upload the program. As we are using a simulation software, we don't require this USB or hardware Arduino Uno. Null emulator. To use the simulator serial port, install a null modem emulator. For communication, the PicSim Lab should be connected to one port of the null modem emulator and the other application connected in the other port. This is the interface of null emulator. We have to select the port pair for serial communication purpose. I have selected COM1 and COM2. So the project requirement number 1. Requirement is garden lights control, and the description is input should be taken from LDR sensor, and the process is read the LDR sensor value and based on the reading from LDR vary the brightness of LED, which resembles controlling garden lights based on the availability of sunlight. So in short, we need to control the garden lights by the position of the sun or the intensity of light present outside. So what is LDR sensor? LDR sensor is nothing but light dependent resistor. Light sensitive devices most often used to indicate the presence or absence of light or to measure the light intensity. So as the light increases, the resistivity of LDR sensor decreases, and as the light decreases, the resistivity of LDR sensor increases. So controlling LED. Controlling LED brightness by using the concept of pulse width modulation. Pulse width modulation is a method of reducing the averaged power delivered by an electrical signal by effectively chopping it up into discrete parts. The average value of voltage and current fed to the load is controlled by turning the switches between supply and load on and off at fast rate. The longer switch period is on compared to the off periods, the higher the total power supplied to the load. So pulse width modulation is nothing but controlling the duty cycle, the time for which the signal is high, and we are controlling the average output. So this is the implementation of the first requirement. We are using Arduino Uno. This is the LED where we are giving PWM signal as an output, which is connected to pin number 3, and we are taking the input from the LDR that is connected to analog pin A1. So as per the requirement, as daylight decreases, resistivity increases and LED brightness increases simultaneously. So at night time, when the resistivity is at its peak, the LED brightness will also be at its peak. I'll be showing you the simulation at the end of this presentation, then we will get the clear idea of this requirement. So the next requirement is temperature control system. So inputs are temperature sensor. The process is read temperature from temperature sensor LM35. We have to output, display the temperature on CLCD, and display the temperature on gauge widget, that is on Blink IoT app. So what is temperature sensor? Temperature sensor is an electronic device that measures the temperature of its environment and converts input data into electronic data to record, monitor or signal temperature changes. In this case, we are using temperature sensor LM35. So as we can see that the input of the temperature sensor is analog, and we previously spoke that microcontroller works on zeros and ones, therefore we need analog to digital converter. So the output of the temperature sensor is analog, thus we need to convert it into digital. This is done by analog to digital converter on Arduino Uno. We don't need an external circuitry for analog to digital converter. There is already inbuilt Arduino analog to digital converter on Arduino. So Arduino Uno has 6 onboard analog to digital converter channels that can be used to read analog signal in range of 0 to 5 volts. The ADC on the Arduino is 10-bit analog to converter, meaning it has ability to detect 1024, that is 2 raised to 10 discrete analog values. So the digital output value calculation, we can do it by V reference, that is the reference voltage, upon 2 raised to n minus 1, where n is the bit range, that is in this case is 10 bit. This is the formula for analog to digital converter resolution. So digital output, that what we will get is V in divided by this resolution. So CLCD, this is the display of a project. The LCD crystal display, liquid crystal display, is a type of display that uses liquid crystals for its operation. Here we will accept the serial input from the computer and upload the sketch to Arduino. The character will be displayed on the LCD. We can see that, for example, this is 16 into 2 LCD, that is 16 columns and 2 rows. So these are the pins of CLCD. A register select RS pin that controls where in CLCD's memories you are writing data to. You can select either the data register, which holds what goes on the screen, and instruction register, which is where LCD's control looks for instruction on what to do next. A read or write pin that selects reading mode or writing mode. An enable pin that enables writing to registers. 8 data pins D0 to D7. The states of these pins are high or low are the bits that you are writing to a register when you write, or the values you are reading when you read. There are also display contrast pins, power supply pins, and LED backlight pins. So I2C interface, what is this need of I2C? So from the previous slide we can see that there are number of pins that we must connect to Arduino to display the data coming from Arduino. But as per the requirement of this project, we have to use number of pins of Arduino, and the Arduino pins are limited. So by using this I2C interface, we will reducing the pin requirements. So 16 into 2 LCD display screen with I2C interface. It is able to display 16 into 2 characters on 2 lines, white characters on blue background, here is green. Usually Arduino LCD displays projects which will run out of pins resources easily, especially with Arduino Uno, and it is also very complicated with wire soldering and connection. For that purpose, we are using I2C interface, because we will run out of the pins. So SDA and L, that is serial data and serial clock, are the 2 pins which we are using. So the requirement number 2, this is 10 millivolt per degree Celsius, that will be changing this LM35's value, which we are giving it to Arduino Uno from analog input A0, and this Arduino is connected via SDA and SCL to this I2C interface, and we will be displaying the temperature values coming from this LM35 sensor. And this is the formula for converting analog to digital, or converting the values to temperature. So an analog read, that is data coming to analog input, into 5 by 1023, that is this is the resolution and this is reference voltage, divided by this 10 millivolt. So Blink is an IoT platform for iOS or Android smartphone that is used to control Arduino, Raspberry Pi, and Node MCU via the internet. This application is used to create a graphical interface or human machine interface HMI by compiling and providing the appropriate address on the available widgets. So this is the operation of the Blink. We need to install a Blink app in mobile, by which we are storing the data or manipulating the Arduino via these mobile devices. This mobile devices data goes to Blink cloud, and we include Blink libraries in our code. We use internet access via Ethernet shield and then giving it to Arduino, and this is the vice versa process from Arduino as well. From Arduino we give the data to Ethernet shield, include Blink libraries in our code, giving it to Blink cloud, and then displaying the values on the Blink IoT app. So this is the cloud interface. This is the name of my project, that is Home Automation. Hardware I am using it is Arduino. Connection type, as I said before, Ethernet. And this is my template IDE that is created automatically when we create this Home Automation page. So Blink configuration: creating account and generating authorization token, creating data streams or virtual pins. So virtual pins are nothing but virtual pins is a way to exchange any data between your hardware and Blink app. Think about virtual pins as a channels for sending data. So these are the virtual pins. I have created 7 virtual pins, that is switch, temperature, virtual pin 2, virtual pin 3, virtual pin 4, virtual pin 5, and string 6. I'll be telling you this virtual pins uses one by one. So before that, we will configure our Blink app on our mobile. Select buttons, gauge, terminals from widget box with respective virtual pins we will be selecting. So temperature sensor is giving values to Arduino Uno, and that value we are giving it to Ethernet shield via virtual pin 1. From the previous slide we can see that virtual pin 1 that is temperature. This virtual pin 1 temperature, that is its range is from 0 to 100. That will be, we will be giving these temperature values 0 to 1 to Ethernet shield, include our Blink libraries in our code, to cloud, and then via blink.virtualWrite, that is a function that can be changed, that can change the values on the app. So the second part of this the requirement number 2 was to display the temperature values on the Blink IoT app. For that purpose, we are the same connection, that is temperature sensor to A0, analog pin A0, taking input from analog pin A0, and this temperature gauge sensor which we created on the Blink IoT app is connected to virtual pin 1. We can see that virtual pin 1. So we are writing the temperature values on virtual pin 1. Therefore I have shown this as virtual pin 1 is going to Ethernet shield, that is temperature are going via virtual pin 1 including Blink libraries to the cloud, and this blink.virtualWrite is the function that we are using to write the values on the app. And here we can see that temperature gauge is showing the result. Requirement number 3, cooler control system. So description about the requirement: inputs, button widget, that is cooler button on Blink IoT app. Process: detect the change in logic level. Output: if the button widget is at its logic high, turn on the cooler. If the button widget is at its logic low, turn off the cooler. Simply we will be creating a button on the Blink IoT app. If the button is on, we have to turn on the cooler, and if the button is off, we have to turn off the cooler. And simultaneously we will be displaying the values on the cooler status on the CLCD as well. So this is the cooler control system. We have this cooler, the fan thing here in the picture. So that is, we are connected to digital pin 4 of the Arduino. That is, why digital pin? Because we need here only 0 and 1, that is 0 volt for off purpose and 5 volts for on purpose of this cooler. So virtual pin 0 as a switch we are using. So pin 4 goes high and cooler goes on. If virtual pins goes 0, pin 4 goes low and cooler goes off. So from Blink app we are controlling the cooler. So blink.write is the function that we are using to control the cooler on Arduino. So we are sending the data to V0 to Blink cloud, to Ethernet shield, to Arduino, and from digital pin 4 to the cooler. Requirement number 4. Same as the cooler control system, we have heater control system. Same inputs, button widget, heater button on Blink IoT app, detect the change in logic level. If the button widget is on, turn on the heater, and if the button widget is off, turn off the heater. So heater we have connected to V2, that is virtual pin 2. When virtual pin 2 is 1, pin 5 is high, heater is on, and if virtual pin 2 is 0, pin 5 goes low and heater is off. We have connected heater to digital pin 5 of the Arduino, and the same process of the cooler goes in the heater control system. So requirement number 5, threshold temperature control. Description: inputs, temperature sensor, process read and compare the temperature with 35 degrees. Output: if the temperature is more than 35 degree, turn off the heater and send notification to Blink IoT app and display the same on the CLCD. So if the temperature is greater than 35, we have to turn off the heater. So when we if we are taking temperature values via A0, that is input, we are giving it to Arduino Uno A0. We are sending temperature values to Arduino Uno, and then we are sending, if the temperature is greater than 35, here we can see that if the temperature is greater than 35, we are sending that data via Ethernet shield, and here we are using 2 virtual pins. This string 6 is for notification purpose. In the requirement we can see that we have to display the notification of Blink app. So we are using this string 6 and heater is connected to V2. So sending it to cloud and blink.virtualWrite, that as I said, to write the values on app. So it will change V2's state, that is on or off. If it is on, it will turn off, and if it is off, it will turn on. So V2 state and notification we are sending. So after it goes to 35, we are sending blink.virtualWrite, that is controlling the values on Arduino. We are using this blink.write, and we are passing V2's state, that is on or off, to cloud, V2 state, that is on or off, to Ethernet shield, to Arduino, and to heater via digital pin 5. And we are done with the requirement number 5. So other requirements of this projects: display the volume of the cereal tank. Inputs: cereal tank. Process: read the volume of the water in the tank by sending commands through serial communication. Output: display the volume of water on the gauge widget. Display the volume of water on CLCD. The requirement number 7, inlet value control, valve control. Button widget, inlet valve button on Blink IoT app. This is nothing but we are creating 2 valves for the cereal tank. That cereal tank is nothing but we can consider it as a water tank at our home, that has two inputs, that is one inlet valve and one is outlet valve. So what is the process? Detect the change in logic level. If the button widget is high, turn on the inlet by sending commands through serial communication. If button widget is logic low, turn off the inlet valve by sending commands through serial communication. And same as the outlet valve. And here we have one additional requirement: read the volume of water in the tank by sending serial commands. We have to read the water level in this serial tank. So I have covered this requirement number 6, 7, 8, 9 in this entire slide. If we go by the simulation, we will get the proper understanding of this slide, but still I will be trying to make you understand. So this is the serial tank. We can see this. These are connected via serial port COM1 and Arduino is connected to COM2. So we are reading the volume via serial.read and giving it to Arduino. If the volume is greater or less than 2000, we are sending it to Ethernet shield. This V4, V5 and string 6 are the virtual pins. V4 is for inlet purpose and V5 is for outlet purpose. Sending it to cloud, and same process, blink.virtual write, we are sending notification that water flow is enabled and water level is full, so via this blink.virtual write. If we turn on the inlet control, here we can see we can turn on the inlet and simultaneously we can turn off the control the outlet as well. And we can see on the CLCD that the display of the water level. I will be showing you the simulation now. So now starting with the simulation of the project. So you can see my mobile phone screen. I am selecting the Blink IoT app and I have created this device Home Automation, the device name Home Automation, and if we are connected to internet, it will show nothing, and if it is not connected to internet, this will show offline. So I have created this Home Automation which is connected to internet. So this is the interface of my Blink IoT app. This is temperature gauge to show temperature values coming from the Arduino, and this is water volume, that is which has the capacity of 3000, which shows the values coming from the serial tank. And these are the buttons, that is cooler buttons, heater buttons, outlet and inlet valve of this volume tank, serial tank. So now on the simulation, so now let's start the simulation. This is the Arduino Uno. We can see that these are the pins that are actively high now. So I have created these interface. So first requirement, one of the requirement was the control the garden lights. So based on the intensity of the light that is falling onto this LDR. So now we can see that LED is fully turned on, as we have written the code in that way that if the resistivity is at its peak, the brightness will be also at its peak. So at night time resistivity is high and the brightness is also high, and during the daytime we can see that as the day resistivity increases, the light starts to fade away, and at zero resistance, that is at daytime, the light is turned off, and again we can see that at night it slowly turns on, slowly brightness increases. The next requirement was to control the cooler. So let me show you my mobile screen again. So this is the cooler button I have created. If the cooler button is on, it will turn on the cooler and it will display on the CLCD that cooler is on, and if I press again, it will show that it will turn off the cooler and it will show cooler is off. Same goes with the heater. If I turn on the heater, it will show heater is on and the temperature increases. We can see that on the app also that temperature is increasing, and once the temperature is greater than 35, we get the notification temperature is greater than 35, turning off the heater, and automatically heater turns off and temperature starts to fall. So next requirement was about cereal tank. So we can see that now the cereal tank is completely filled up to 3000 liters. We can see that here water volume is this 3000 liters is completely filled. Now once we turn on the outlet, water level will start to decrease. So I'll show you. So I have turned on the outlet and we can see that water level start to decrease, and simultaneously the water volume also start to decrease on the gauge we have created. And once the volume is less than 2000, we have written the code in such a way that it will turn on the inlet automatically if the water level is less than 2000, and we can see that it will start to fill up to 3000. On the CLCD we can see that temperature volume is getting updated, and once the level is up to 3000, we get the notification that water level is greater than 3000 liters, turning off the inlet. So this was about the entire project, the home automation solution. We have controlled the lights, we have controlled the garden lights, we have controlled the heater, cooler, we have also displayed the temperature on CLCD, also the status of the heater and cooler, status of inflow and outflow, and the volume of the water on CLCD. So this was about the simulation of the project. So at the conclusion, once again I would like to thank the Emertxe Institute for providing us this free internship opportunities. The internship was the entire internship period was very enjoyable, very knowledgeable. I got to learn various skills about IoT, embedded system, C language, etc. I would also like to thank teachers for clearing our stupidest doubts in a gentle and kind ways within no time. Thank you.